Hi, today we are doing a seismic analysis on a building. Here is all the members which we drawn and applied the material property. This is a seismic load pattern. You can see in direction X and Y direction. You should check. And this is the seismic zone factor. We have to refer IS 1893. This is you can see in blue location. Our location is Bangalore, which is zone 2. For zone 2, we have to see the table number 2. Okay. Table number 2, which is 0.1 seismic zone factor. Then important factor is 1, and response factor, reduction factor, we have to see here. Okay, you can see this is our OMRF, ordinary RC moment resisting frame. Okay, we add it and click on OK. Then we have to run the analysis. Okay, you can see here we added a do not run for the wind. We are running for dead, live, and for seismic load. The analysis process is going on. Okay, it is going on. Now you can see the displacement pattern of the building. Then we can easily see the moments and shear force. And now we have to design. Okay, the design has been started. It is going on. You can see the at the bottom the progress is going on. We have to wait for a little time. This process might get some more time depending upon the configuration of the system and the model type which we created. You can see all the reinforcement details are going on. We have to click or right click and you can see the reinforcement detail. Here is the report. You can generate a report by going to the project report. Okay, this is the report. In this report you can get all the details and what load we are doing. Now we are designing a building by using a response spectrum function. For the same building we have to add a response spectrum. You can see IS 193. Then we are going to rename it. Function name, we added a function name. Okay, response spectrum. Now add a seismic zone factor which is for Bangalore as it is as we added a previous case. Okay, now we added a response spectrum. Now go to the display unit, check the acceleration unit which is mm per second square. Okay, it's correct. Now go to the load cases. Okay, we're adding a new load case for response spectrum. Okay, load case type, now response spectrum. Okay, we are adding a loads u1 u2. You can see how we find the scale factor. Okay, click on OK. Okay, next we have to analyze. So we are going to off the wind for dead and live. We don't want to run, do not run. Okay, now we are running analysis for the seismic and for the response spectrum. The analysis is going on. Okay, the building is analyzed. Now we are designing a building. Okay, building is designed now. You can see all the reinforcement detail. Now we are designing a seismic analysis for a building by using the time history history function. You can see we have already added a seismic layout. We have to modify this only in a x direction. We have to add. Okay, click on OK. Then we are defining a function for time history function. Okay, we are selecting a file which is for a. Okay, we already have a one file of the earthquake data. Okay, now we are adding. Okay, okay, this is what the Bhuj earthquake which is undergone in 2001. Okay, we are added all the parameters. Okay, now click on OK. Now just go to the load cases. We don't want this response spectrum. We have to add a new, which is a time history. Okay, add the time history. Okay, load factor we have to calculate. Okay, now click OK and OK. Now run the model. Okay, analysis part is completed. Now just go to the design of the concrete. Okay, it might take some time. Okay, finally we got all the reinforcement detail. If the member is failed, we have to revise the section. Okay, now last part is of detailing in progress. Okay, now done. Now you get all the details like beam tables, concrete tables, etc., and columns in a render view with all its shear reinforcements. Okay, now we can generate a project report which consists of the all parameters and all the added loads. Okay, thank you for watching. Bye bye.